Hi lads, in this video I'm going to go through two different things. First of all, I'm going to go through how to draw a tetrahedron, and then secondly I'm going to go through how to inscribe and then circumscribe a tetrahedron. So the first thing about a tetrahedron, basically a tetrahedron is the simplest possible polyhedron. It has 4 faces, 4 vertices and 6 edges. So you can see there, just in 3D view, there's 4 faces, one on the back, one this side, one here, and then the base has 4 edges, 4 vertices and 6 edges then as a result. As well as that, they're all made up of equilateral triangles. So all the faces, so if we look in the plan here, we can see a true shape of the base, and then all of the other sides are then folded in on top of there at that point. So the other 3 sides there are folded in. So first thing I'm going to do is, I'm drawing a tetrahedron. We draw our plan first. What I'm going to do is just take my XY line across here, and I'm going to put my plan low enough because I'm going to fit both these questions in together and save me redrawing it again. So what I'm going to do is, I'm going to set my side as about 60 mil, let's say. So because it's an equilateral triangle, all sides are going to be 60 mil as a result. So to find our center point, so basically the apex, which is this point here, I can take this line straight up because that bisects that angle there, and then just bisect this angle then where the 2 meet. I get my center point then for the top. So I take that line up there, and then very simply I just bisect an angle, take any distance on my compass, just let that focus there, and then swing an arc there and there, stretch my compass out a bit, swing it from my 2 new points, and where they cross, at that point there, I join that back. And that gives me the apex of my tetrahedron. So therefore giving me my 4 faces, so this one, this one, this one, and then my base, obviously the whole thing being 1 as well. What I'll do is just take all my lines up there. So I don't know the height of it yet. So the only way we can find our height is by looking in at our end view. And you'll see now in a second why that actually works. So let's take my points up again. So my top point is lying somewhere along that line there. You can see when focus will point it out again to you. So you can see top point is going to lie along that line there somewhere. And I think we know about the tetrahedron is all sides are equilateral triangles, therefore all the lengths of each side are going to be the same. When we look at our base, we can see our true length here are given to us as 60 mil. If I look in at my end view here, we always remember that a line, when we look in this way, is going to be perpendicular in this case to the XY line. It's going to be a true length in our end view. So basically by looking in there perpendicular, we'll be able to see the true length of that line. So if we take our 60 mil, we're able to apply it from the ground here, because when we look in and turn around this way, we're able to see it as a true length. So that gives us that length there as a true length, and also gives us the height of our tetrahedron, and that point can connect to the ground there. Then we can take our height across to our elevation, and therefore draw on our elevation as a result. there's our elevation, plan and then view of our tetrahedron. So for the next part, I'm going to show you how to inscribe and circumscribe it. So basically putting a sphere that fits inside the tetrahedron and also drawing a sphere that circumscribes, basically touching the outside of it as well. The first thing, because it's an edge here in our end view, we can bisect this angle here. That will help us find our center point. So when I show you in class the SOLIDWORKS model, you'll be able to see it makes more sense. So we bisect that there, and then we take our point straight down here to give us the center of our sphere. What we can then do is find the exact point of contact where it hits that edge there. We go perpendicular to this edge here, so almost like it's a tangent point. And that gives our radius of our inscribed sphere. There's one of them. The height never changes, so I just measure up there. There's our second one. Our third one just occurs here. You can see that in all three views, apart from our edge view here, we can't see where it's touching off the other sides, but in the actual model you'll be able to see that because this face, and this face are all folded in each other, the sphere is actually touching off all of those at a certain point. You just can't see it, same with this view here, and you'll be able to see in the model how it actually works, and I show it to you in class. So the next thing then is our circumscribed sphere, so where the sphere touches the outside points. So once again we have our edge view. And because it's a true length, we're going to see it touching off this point here and this point here. So the centre will stay the same, and all we need to do is stretch our compass out to our edge there as a result. Because they share the same centre. I just need to rub out a small part of there just where my compass slipped, but you can see where it goes to the top point there, that point there, and goes the rest of the way around. It's just there, just tidied up so you can see how it passes exactly through the top point and this point here, and then the rest of the way around. So once again the centre stays the same, so you can see this time in my elevation it's going to pass through the front, or sorry, pass through the top point there. Even though it doesn't pass through the other corners, you'll see through the model that it actually will. And the last one, same centre again, we draw our sphere then to circumscribe it. So hopefully that video helps anybody who might be stuck on that question there.